The Hubble Space Telescope, which was launched in 1990, has captivated the world with its stunning images of space and has significantly expanded our understanding of the universe. Despite being relatively small in size compared to ground-based telescopes with massive mirrors up to 10 meters in diameter, the Hubble remains one of the most powerful instruments for studying the cosmos. Its 2.4-meter mirror, while considered standard for modern research telescopes, has consistently outperformed many advanced ground-based telescopes. It continues to be at the forefront of optical and ultraviolet astronomy, with a demand for its usage and research that far exceeds the available observing time each year. Traveling at a staggering speed of 17,500 miles per hour, the Hubble has covered a distance equivalent to a journey to Neptune, the farthest planet in our solar system. It has peered into the distant past, capturing images from locations more than 13.4 billion light-years away from Earth, and has conducted over 1.3 million observations since its mission began in 1990. Among its notable contributions is helping determine the age of the universe, which is now estimated to be approximately 13.8 billion years old, roughly 3 times the age of Earth. The Hubble has also played a role in the discovery of 2 moons of Pluto, named Nix and Hydra, and has contributed to our understanding of the universe's rate of expansion. Additionally, it has created a 3D map of dark matter, shedding light on the mysterious substance that makes up a significant portion of the cosmos. One of the most intriguing discoveries made possible by the Hubble telescope is the identification of a celestial object that challenges our understanding of the solar system's composition. In a surprising announcement, Caltech astronomer Michael Brown revealed the existence of a new planet larger and more distant than Pluto. This new object was named 2003 UB313 and is the most distant directly observed body in the solar system, ranking as the 4th brightest object in the Kuiper Belt. Brown and his colleagues, Chad Trujillo and David Rabinowitz, made this groundbreaking discovery, emphasizing that this newly identified planet is undoubtedly larger than Pluto. The debate over Pluto's planetary status has raged in recent years, with many astronomers arguing that Pluto should no longer be classified as a planet. However, Brown and his team argue that if Pluto is granted planetary status, it is inconsistent to deny it to even larger celestial bodies. Pluto itself orbits the Sun among hundreds of other objects in the Kuiper Belt, a region located between 30 and 55 astronomical units, or AU, from the Sun, where 1 AU is equivalent to approximately 93 million miles, or 149.6 million kilometers. The significance of 2003 UB313 lies not only in its size, but also in its extreme distance from the Sun. At the time of its discovery, it was the most distant known object in the solar system. Sedna, another planetoid, was previously the farthest known object and never gets closer to the Sun than 76 AU, currently residing at 98 AU. In contrast, 2003 UB313 is an astonishing 97 AU from the Sun, equivalent to over 9 billion miles or 14.5 billion kilometers, and has reached the farthest point in its 560-year orbit. It will approach its closest point to the Sun at a distance of 38 AU in about 280 years. The reason 2003 UB313 remained undiscovered for so long lies in its unique orbital characteristics. Unlike most planetary orbits, which are relatively aligned with the elliptical plane, 2003 UB313's orbit deviates significantly, with a 44-degree tilt relative to the plane. This unusual orientation made it challenging to detect, as astronomers typically concentrated their search efforts within the plane of the solar system. The initial observation of 2003 UB313 occurred on October 31, 2003, when the team used the 48-inch Samuel Oschin telescope at the Palomar Observatory. However, the planetoid's slow movement caused astronomers to overlook it until a reanalysis of images revealed its presence. Subsequently, on January 5, 2005, Alan Stern, an astronomer at the Southwest Research Institute, described the discovery as cool but not entirely surprising. Stern, who also led NASA's New Horizons mission to Pluto, had previously predicted in a 1991 paper that the Kuiper belt and the Oort cloud would contain numerous large objects. He argued that collisions with such objects had influenced the axial tilts of Uranus and Neptune. Stern further contended that the asteroid series should also be considered planets, based on the criterion that any celestial body with enough gravity to become round should be classified as a planet. Stern's perspective challenged the traditional definition of planets and raised the possibility of dozens of planets in our solar system, ushering in a new era of planetary classification. He referred to these potential additions as dwarf planets. Stern believed that just as the majority of stars in the galaxy are small, cool dwarfs compared to our Sun, ice balls like 2003 UB313 could be the most common type of planetary body in the galaxy. Brown and his team conducted extensive observations of 2003 UB313 using multiple telescopes to better understand this distant world. They obtained a near-infrared spectrum of the planetoid's surface properties using the Gemini North Telescope on Mauna Kea, Hawaii. Preliminary findings revealed that the surface of Pluto is covered in frozen methane, suggesting that it has retained its primitive characteristics since the formation of the solar system approximately 4.5 billion years ago. If 2003 UB313 had ventured closer to the Sun, its methane ice would have melted, but no other object in the Kuiper belt exhibits a surface like this. Interestingly, 2003 UB313 appeared nearly gray in color, unlike Pluto, which has a somewhat reddish hue. The reason for this color difference remained unexplained at the time. The amount of light reflected by 2003 UB313 presented a limitation in assessing its size. Brown pointed out that even if the planetoid reflected 100% of the sunlight it received, it would still be similar in size to Pluto. However, no known substance possesses such high reflectivity, and the dimmer the object's surface, the larger it must be to appear as bright as it does. Brown estimated that if 2003 UB313 reflected 90% of sunlight, like freshly fallen snow on Earth, it would be slightly larger than Pluto. He suggested that 2003 UB313 was roughly 1¼ times the size of Pluto, equivalent to approximately 1,777 miles or 2,860 kilometers across. Attempts to detect the planetoid with the heat-sensing Spitzer Space Telescope had not been successful up to that point, but astronomers remained determined to investigate further. While the name 2003 UB313 was provisional, Brown's team had submitted a permanent name to the International Astronomical Union for approval. They opted to keep the proposed name confidential until it received official recognition. Brown also revealed that the planetoid would be visible for the next 6 months and was currently located nearly directly overhead in the early morning eastern sky in the constellation Cetus. He estimated that an amateur astronomer equipped with a 14-inch telescope, a CCD camera, and a dark observing location could potentially detect the object. Despite its intriguing characteristics and significance, 2003 UB313's remote location and small size make it challenging to observe effectively without advanced telescopes. There were no immediate plans to send spacecraft to study it up close, but powerful observatories like the James Webb Space Telescope were expected to play a crucial role in further exploring this distant world. The James Webb Telescope's website even identified 2003 UB313 as one of its targets and aimed to provide insights into the planetoid's properties. As the scientific community continued to unravel the mysteries of the solar system, the discovery of 2003 UB313 represented a fascinating chapter in our ongoing exploration of the cosmos. Which aspect of 2003 UB313's discovery do you find most intriguing? Share your insights and opinions. Don't forget to hit that subscribe button and ring the notification bell so you never miss out on our exciting updates about lunar discoveries and the future of space exploration. Remember, as we venture into the universe, the sky is not the limit, it's just the beginning. Keep looking up.